Okay, this is a continuation of the 2016 AP Calculus practice test, the official practice test. We're going to do multiple choice 24 through 30. This will be a pretty short video. So number 24, so I definitely think one like number 24 could be on the 2020 test. Says to take the limit as x approaches 3 of the tangent of x minus 3 over 3e to the x minus 3 minus x. So if you plug in 3, you're going to get 0 over 0, indeterminate form. So you want to use L'Hopital's rule and take the derivative of both the top and the bottom. And go ahead on your work when you're taking the test, do something like that. Okay, so just to tell them you're using L'Hopital's rule. So the derivative of tangent is secant squared. And the derivative of the blop is 1, so you don't have to write that. And then the derivative of e to the x minus 3 is just e to the x minus 3 times 1. So that's going to be 3e to the x minus 3, and the derivative of x is 1. Now we can go ahead and plug in a 3, so secant squared of 3 minus 3 is 0. And then that would be 3e to the 0 minus 1. So what is secant squared of 0? Well, remember secant goes with cosine. Cosine of 0 is 1. Make sure during the test you have your unit circle out ready to go. Cosine of 0 is 1. So flip that. Secant of 0 would also be 1. E to the 0 is 1, so 3 minus 1 is 2. So the answer is 1/2, which is option C. Okay, that's a good one to study. I definitely think if you're going to have a limit on the test, you know, you'll probably be able to use L'Hopital's rule on it. Number 25 says we have f prime of x is equal to 3x squared minus 6 over x squared. So they've given us a derivative, and they also say we know two things. We know that f of 1 is equal to 9, and f of 3 is equal to 11. And it says what value of x in the open interval 1 to 3 satisfies the mean value theorem. Remember, mean value theorem means that the slope of the secant line is equal to the slope of the tangent line. I can get the slope of the secant line from this information right here. And then I can set our derivative equal to that slope and see what value for x gives me the slope of the tangent line equal to the slope of the secant line. So this would be our y value. This is our x values. So our secant slope is just going to be y2 minus y1 over x2 minus x1. So 11 minus 3, 11 minus 9 over 3 minus 1. Okay, so that's 2 over 2, which is equal to 1. So our secant slope is equal to 1. If we set our derivative equal to that, we can find the x value where the tangent line slope is equal to 1. And that's what it's asking for. So 3x squared minus 6 over x squared is equal to 1. Let's multiply both sides by x squared. We'd have 3x squared minus 6 is equal to x squared. So 2x squared is equal to 6. X squared is equal to 3. So x is going to be the square root of 3. I know it's plus or minus the square root of 3. But it asks for the interval between 1 and 3. So negative wouldn't do that. And on our sheet, that is option B. Of course, the 2020 test won't have multiple choice on it, but I do think that these problems are valuable. that they can help you answer the free response questions. So that's why I'm working them for you. Okay, so pause video if you need to. Okay, number 26. I don't believe you'll see one like that on the test. And let me tell you why, just real quick. It says, it just gives you an integral to evaluate. And what you have to do is you have to use long division of polynomials to divide x plus 2 into x squared minus x minus 5, which you might have done in Algebra 2, but you probably didn't. I have never worked one on an official AP test. This is the only one I've ever seen where you have to use long division to simplify an integral. So I really don't think you're going to see one like this on the 2020 test. Yes, you might have to evaluate an integral, but I don't think, use substitution wouldn't work here. You literally have to divide x plus 2 into the top here. And we could go through how to do that, but I just think it's a waste of time. So I'm going to say not on 2020 test. Okay, 27 absolutely could be. I think it's a related rates problem, and I think that related rates, you absolutely might see one of those on the test. It's definitely fair game. So just pull this into view here. We've got a spherical bowl, or not a sphere, but a round bowl, and it says the radius of excuse me, it has a radius of 6 meters and it's losing water. It gives you the area of the surface area of the surface. It gives you a formula on how to get that. And it says when height is 3 meters, the depth of the water is decreasing at a rate of 0.5 meter per minute. What's the rate at which the area of the water surface is decreasing with respect to time? So what is the rate at which the area is decreasing? So what do we want? We want dA dt. What do we know? Okay, we know that the depth of the water, which is h, is decreasing at a rate of 0.5 meter per minute. So minus 1/2. And relate, they gave us the formula, thank goodness. So they gave us a formula that area is equal to 12 pi h minus pi h squared. So, you relate what you want to what you know. So it has to have an A for area in it. It has to have an H for height in it. And as always on related rates, we differentiate with respect to time. So I'd have dA dt is equal to, 12 pi, and then the h is going away, right? 12 pi, but don't forget the derivative of h is dH dt. And then minus, bring that 2 out front, 2 pi h dH dt. Okay, so now let's just plug the numbers in that we know. We've got 12 pi minus 1/2 for dH dt. And let me rewrite this as dH dt equals minus 1/2. Sorry about that. Okay, minus 1/2 minus 2 times pi. What is the height? This is from the depth of the water. It's 3 at this particular point in time, minus 1/2. And now it's just a matter of, going through there. So that'd be minus 6 pi and then plus 3 pi. So that is minus 3 pi. And its area, so that would be, the area would be meters squared, right? You've got to get the units right on this test since it's free response. So meters squared per minute. Unit of time, area is going to be a distance squared divided by a unit of time. So that's something on a multiple choice you don't have to really worry about the units, but on the 2020 test you do. Okay, pause if you need to. All right, 28. Okay, it says two vertices of a triangle and a third vertex is on the graph. Y is equal to natural log 2x minus 1/2 x plus 5. And we've got a graph, and it says two of the vertices are on the x-axis here. So you've got one at 1 and the other at 5, and then somewhere up here is a y value that will make this triangle a maximum area. Okay, so in order to get the area, we know that the area of a triangle is 1/2 base times height. And of course the height is going to be y. Okay, the height is y. The base is going to be from 1 to 5, so the base will be 4. So our area is going to be 1/2 times 4 times the height of y, natural log of 2x minus 1/2 x plus 5. So area is equal to 1/2 times 4 is 2, so 2 natural log 2x, and then 2 times negative 1/2, right, would be minus x, and then 2 times 5 would be plus 10. So how do you get a max? Well, a maximum area, you take a derivative, a prime. All right, so that's going to be, what's the derivative of natural log of 2x? It's 1 over 2x times 2. So I've got 2 times 1 over 2x times 2. And then the derivative of x is 1. And then the derivative of 10 is 0. So that's going to be 2 over x minus 1. How do we find the critical point? We set that equal to 0. So x is going to be 2. That's our critical point. Okay, you can check to see if it's a maximum by doing a sign line, but I'm going to tell you it is a maximum. Otherwise, the whole thing wouldn't work. Okay, but you could check. So in order to get the height of this thing, all right, we've got to plug, we know that our x value is 2, so we've got to plug in 2 into y. So y of 2 is equal to our height. Okay, so that's the natural log of 2 times 2, which is 4, minus 1/2 times 2, so minus 1 plus 5. So that's the natural log of 4 plus 4. Okay, that's not the answer, and it's not one of the values. That's just the height. So our max area, so this is a long problem. It's 1/2 base, which we know, times height, which we just figured out. So 1/2 base is 4, and then the height is natural log of 4 plus 4. So 1/2 times 4 is 2, so that's 2 natural log 4 plus 8. That's a lot of work, but it is C. You know, I think this is a valuable one to understand. I kind of doubt that they would give you one that looked exactly like this on the 2020 test, but you know, it's good to practice getting maximums, and I could see it happening that they could ask you something like this. All right, we're moving on. Number 29 says f of x is equal to x cubed plus 4x plus 2. G is the inverse of f, and g of 2 is equal to 0. What is g prime of 2? Well, it's really hard to figure out what g is from this. You have to swap x and y and then solve for y, and this is a really tough one to do since it's a cubed. So there's a formula for this. And what it is, first of all, you have to figure out the derivative, f prime of x. Okay, we had a worksheet on this during the year, and you've got the worksheet in your notebook somewhere. It's in chapter 5. But that's going to be 3x squared plus 4. So g prime of 2 is equal to, here's the formula, 1 over f prime, which we just figured out, of 0. Okay, if you know g of 2 is equal to 0. So f prime of 0. So that's going to be 1 over f prime of 0 is 3 times 0 squared plus 4. So that's 1/4. So that is option C. All right, just the formula. If they give you the original function and then a point on the inverse function, you can get the value of the derivative of the inverse at this point right here. Okay, and number 30. All right, number 30 is, I don't believe it's going to be, you're going to see one like this on the test. It's possible. It's a Riemann sum type of problem to see if you recognize, you know, base times height and that kind of stuff. But I don't see them asking you one like this on a free response. So, and I don't think it's worthwhile for us to go over it. So out of this video, 2 of them I didn't think were really worth looking at for the 2020 test. So we'll pick up on the next set of multiple choice where you do get to use your calculator. And on the 2020 test, you will get to use your calculator on the whole thing. And you will have open notes, open internet. Okay, it's open everything. So I will talk to you next video.